Hi everyone, today we had KCET Physics 2025 and one of the question that appeared in that exam was this question. So let me describe the question. It says there are two wheels which are connected by a non-sleeping belt. This non-sleeping word is very important. The radii of the two wheels are given as 20 centimeter and 30 centimeter. And I1, I2 are the moment of inertia of the two wheels. They have applied a torque of 10 Newton meter on the smaller disc. So let us assume the torque is in this direction, okay, clockwise. So here there is a torque of 10 Newton meter. We have to find angular acceleration of this disc. Alpha generally we use for angular acceleration, right? So we have to find angular acceleration of first disc, second disc and torque acting on the second wheel. Now how do you solve this question? Well, the main thing here to understand is non-slipping condition, which means that there is no slipping between the belt and the wheels. So if this is your wheel, and as it rotates, let's say at some time this point on the wheel has, let's say, velocity v, tangential velocity, okay. Now the belt which is in contact with this, the point of the belt which is in contact with the point on the wheel, those 2 points must have same velocity. That is the meaning of no slipping. Okay, for example, if there are two surfaces like this, if this is moving faster, then we say there is slipping, or if this is moving faster, then we say there is slipping, right? No slipping means both the surfaces should move with same velocity at every instant. So the point of the wheel and the point of the belt in contact should have same velocity at every instant. That is the meaning of no slipping. Okay. Now if they have same velocity at every instant, then it means acceleration of those two should be same in this direction. Why? Because let's say initial velocity is 10 meter per second for both of them. Now because it is rotating faster because of the torque, the wheel may have after some time 12 meter per second. But they told no slipping. So belt which is in contact here should also have velocity 12 meter per second. So if both the wheel and the belt have same initial velocity and same final velocity in a given interval of time, then it means acceleration also should be same for both of them, isn't it? Because acceleration is final velocity minus initial velocity divided by time interval in this direction, right? Now that acceleration for the wheel in this direction is your tangential acceleration, okay, because wheel also has centripetal, remember. So in this direction, whatever acceleration the wheel has, that is called tangential, and that must be same as acceleration of the belt. And same situation should happen here also, isn't it? So tangential acceleration of the first wheel here and tangential acceleration of second wheel here, that must be same as acceleration of the belt. So now this point on the belt and this point on the belt should have same acceleration, isn't it? Because this line is inextensible. If this point of the belt has more acceleration than this point, this length will increase, right? And if this point of the belt has more acceleration than this point, this length will decrease. But this length is fixed. So acceleration of the belt here and here should be same. That's why I have used same symbol for acceleration of belt here and here. Okay. So therefore, tangential acceleration of first disc and second disc must be same at this point. Okay. Now we know that tangential acceleration is rate of change of tangential velocity. And when a particle goes in a circular motion, the tangential velocity or linear velocity is given by r omega, right, where r is the radius of the circle in which this particle is moving, in this case r1, and omega is the angular velocity, but r is constant, so you can take it outside, and this is called rate of change of angular velocity, which is called angular acceleration, written as alpha. So tangential acceleration is what? R alpha. So tangential acceleration of first disk will be r1 alpha 1, and for second disk will be what? r2 alpha 2. So these two should be same because of no slipping condition. Okay. Now the question is very simple because they have given you torque and moment of inertia of the first wheel. So using Newton's law, torque equals to I alpha for rotation. We can write torque on the first disk equals to moment of inertia of first disk and angular acceleration of first disk. So torque was given 10, moment of inertia is given 4. So angular acceleration of the first disk will be 10 by 4, which is 5 by 2 radian per second square, isn't it? 2.5, but in option they have given 5 by 2. Now how to find angular acceleration of second disk, the bigger wheel? Well, we can't use this formula because we don't know torque on the second wheel, but we know this condition which came from no slipping condition, right? So you substitute here. What is radius of the smaller wheel? 20 centimeter. Angular acceleration of the smaller one we found 5 by 2. Radius of the bigger wheel is 30. And angular acceleration we have to find alpha 2. This is also centimeter, so centimeter will cancel. That's why I didn't convert into meter. 0 0 cancel, 2 2 cancel. So angular acceleration of second disk will be what? 5 by 3 radian per second square. And now we can use Newton's law in rotation to find torque on the second wheel, which will be I into alpha for the second disk. I is what for the second wheel? 20 in SI units, and alpha is 5 by 3. So this will be 100 by 3. SI unit is Newton meter. So this is your torque, not alpha. So tau I should write, isn't it?